Okay, and good morning, everybody. My name is Silvana Masella. I'm the CEO of Trust IT Services and the project coordinator of ICT Footprint.eu that brings to you these dynamic webinars. We are now on our 5th webinar, our second, I believe, in 2017, and we have a set of wonderful speakers for you. If we have a look at our webinar title, it is Solutions for Energy Management and Lifecycle Assessment, LCA, in ICT. And with us, and joining us on today's webinar for an hour, will be Jean-Marc Alberola, who's the Vice Chairman of the group at ETSI ISG-OEU, and he's the Energy Strategy Leader for Airbus. Now, Jean-Marc is at the origin of the Airbus Group Energy Network and has designed the energy strategy for the group. Our second two speakers who will be dividing their presentation up from EcoInvent are Fadri Casti, who's Head of Sales and Business Development and is responsible for the worldwide sales of the LCA database at EcoInvent, and his colleague Teresa Levova, who's a project manager and environmental project manager at EcoInvent. And our final speaker is Berina Delalic from the multEE project. She is a component leader and is a technical expert for the project of the Open Regional Fund for high-level zooming in of ICT Footprint, and then we'll move into our first speaker of the webinar. So ICT Footprint.eu, the fact that we're putting on these webinars, and we have 10 to do in a total of 36 months, this is one part of the activity we're looking at, is to sensibilize our European audience on how they can try and reduce their ICT carbon footprint. And we want to become, and we hope we are, the consolidated effort in Europe that helps raise awareness on different types of products or services or solutions on offer from organizations that help measure the energy and environmental efficiency of the ICT sector. You can see from the slide deck we have listed who our stakeholders are, and with that we want to have an opportunity with ICT Footprint to actually provide a platform for these organizations who have already or in the pipeline their own tools or products and services that can be introduced to help you understand your lowering your carbon footprint in ICT. And with that, we've indicated here our major outputs. So I said we were a support activity that helps spread the word on lowering your ICT carbon footprint. And with that, we're pulling out this marketplace for both buyers and sellers, so you can find or sustainable ICT suppliers, or you can publish your ICT sustainable services. A series of webinars where we actually learn something around this topic. A help desk in 5 languages. We're also interested in listing success stories around the globe on how organizations are making energy savings on getting their carbon footprint reduction. And then I think the nicest thing that we have as a challenge over the 36 months is actually to put together a self-assessment tool for organizations to help you measure your own carbon footprint. So without further ado, I shall move in to pass the floor to our first speaker of the webinar today.
Okay, thank you very much, Teresa, for this kind of introduction, and thank you also for ICT Footprint to giving me the opportunity today to present our KPI we have developed in the scope of ETSI. My objective with this presentation today is to introduce this new standard to monitor the energy management performance of data center and ICT sites in operation, and to demonstrate how it is implemented in our site at Airbus. This standard has been developed under the umbrella of the ETSI, ETSI is a European Telecommunication Standard Institute, produces a globally applicable standard for information and communication technology, called the ICT, including fixed, mobile, radio, converged, broadcast, and internet technologies. This standard enables the technologies on which business and society rely. ETSI is officially recognized by the European Union as a European Standard Organization. ETSI is not for-profit organization with more than 800 members organization worldwide, drawn from 68 countries and 5 continents. Members include the world's leading company and innovative research and development organization. For more information about ETSI, I invite you to visit the website www.etsi.org. Before I present the standard, let me coming back to the EU policy framework from climate and energy targets. To support climate change policy, the EC has defined targets at the horizon 2020, 2030, and 2050 about greenhouse gas emission reduction, consumption reduction, and renewable energy. The EU is committed to reduce its greenhouse gas emission 20% below 2019 level by 2020 and intends to achieve a further reduction to 80-95% by 2050. In addition, renewable sources should cover 20% of the final energy consumption in 2020 and a large part of it by 2050, as identified in the Energy Roadmap 2050. In this frame, the European Commission asked ICT industry to develop a framework to measure its energy and environmental performance and set energy efficiency targets. This slide presents more in detail the EU policy framework and especially the part related to ICT sector. We should not have to read all these boxes. What we could highlight here are the large-scale deployment of smart city solutions in Europe focusing on intersection of ICT, energy, and transport, and the aim to increase the contribution and integration of renewable sources, which is at the origin also of our standard development. ICT Footprint Project provides on its website. I would like to invite you to have a look on this website. You can find a lot of interesting information. And this page is a mapping of the ICT standard developed in the EU policy framework for climate and energy. Some of these standards address the request of the European Commission about measuring the energy and environmental efficiency of the ICT sector. I will focus in the next slide on the ETSI Standard 200-200, classified here as organization project, even if this standard have also a large implication on the smart city. ES means ETSI Standard 205-200 series is about global KPI of operational ICT sites. Document 1 at the top of the slide is about general requirement. This is an umbrella document. Subseries 2 describes KPI for all operational infrastructure as ICT site, as well as fixed and mobile access networks. Document 3 defines a single global KPI DCEM for ICT sites. A European norm is under development in the scope of the mandate 562 given by the European Commission to the European Standard Organization. and it will be the implementation of the ETSI Standard. The number of this draft of norm is 305-203. At this stage of the presentation, I just would like to highlight that we have defined only one global KPI for ICT site dedicated to data treatment and data transmission, including all type of ICT site from the data center to a transceiver shelter considered as a standalone site or group of sites. To understand why this standard has been proposed by the group of users, we have first to clarify the discrepancy between technical KPIs and objectives KPI. Here in blue, technical KPI are defined for specific conditions and are useful to assess the performance of subcomponents and the design and implementation phases. They are essentially unable to manage that consumption in operation. An example of such a product would be a power supply unit, a UPS, which may be more efficient under higher load conditions. The procurement of products and systems based upon the technical KPI for energy consumption and or task efficiency underpins the relevant objectives KPI. Objectives KPIs on the right part of the slide are related to specific elements of energy management, operational infrastructure under the control of the operator as follows. Objective KPI define requirements for the measurement of operational infrastructure, taking into account the real operating condition over a defined period of time. The DCEM, which means Data Communication and Processing Energy Management KPI, has been defined by the Industrial Specification Group, EUE, Operational Energy Efficiency for User, of the ETSI. DCM KPI is a combination of 4 objective indicators. Energy consumption, which is the total consumption of energy by an operational infrastructure. Task efficiency, which is a measurement of the work done as a result of design and operational procedure for a given amount of energy consumed. Energy reuse, transfer of or conversion of energy, typically in form of heat, produced by the operational infrastructure to do other work. And renewable energy, which was a big request from the European Commission, energy produced from dedicated generation system using resources that are naturally replenished. Objective indicators aim to define the measurement requirements in operation of ICT site, taking into account the real condition. This graph presents the DCM construction and the detail. We can have detail on the specification document from the ETSI. I will not go in detail. You can see here the 5 KPIs and the 2 weighting factors depending of the size of the data center and the performance of the site. The weighting factor used in the DCM KPI could be fixed in accordance with the regional energy policy in order to incentive one or both action. At the end, we are able to define a class of performance for the data center. Implementation on Airbus sites. DCM standard report has been deployed on all Airbus data centers in Europe using our own energy management software. Standard reports integrate aim to implement the calcul of the DCM and the objective KPIs, which are part of the standard. This analysis helps the team in charge of the infrastructure management to monitor the operational capacity of the data center in terms of power and also in terms of cooling availability, to identify the performance deviations, and to monitor the level of efficiency, and to verify the efficiency of the action of saving implemented or in commitment. A non-governmental organization, EG4U, is in charge to promote this DCM KPI. They have their own. We have our own platform, which is under development, able to all the members of the organization to make their own assessment and to benchmark with all the other members. In conclusion, I would like to back to some advantage for using this type of KPI. It's one single operational global KPI, which is defined by the user and for all type of ICT sites. We can use it to formulate target, trend, and to make some comparison at the size of the data center. This is a good instrument for the development of environmental policy for land and regions, to define future environmental taxes, incentive specification, and to integrate also flexibility for policy making by using weighting factor integrated in the DCM calculation. It's also useful for the ISO 50001 certification because it addresses the chapter 5 regarding energy performance indicators and the operational control. To achieve for this point, it's also a KPI which is development free of manufacturer influence. It's completely integrated in the objective of the COP21, and I would like also to add that this KPI aim to support the development and the implementation of renewable energy sources and energy reuse. I'm at your disposal for everyone who would like to implement, who try with this new KPI. You can find some information on the ETSI website and also on the EG4U organization. And also I can invite you to participate to our workshop we do in Bordeaux in June, making smart cities sustainable. Thank you for your attention.
Thank you very much, Jean-Marc, for that very interesting insight around a specific industry specification group around energy efficiency for users. Before we move on to our next speaker, I would like to pick up a couple of questions for you. What is, Jean-Marc, based on your experience, the strategy that you could recommend for data centers to become more efficient in their energy consumption?
Yeah, based on my experience and the relationship I have with my colleagues who are managing the infrastructure, the strategy we have deployed at Airbus was first to, maybe first I have to start about what is the challenge and the team have to face today. The first one is is really to make place to put new equipment in the existing infrastructure. With the deployment of the digitalization in the industry, there is more and more needs in terms of implementation for equipment for ICT. The second point for our team is also to manage physically the data center, to contribute to the environmental target of the company, and also to have some monitoring about the evolution of the ICT sector, especially in terms of regulation, and to anticipate what could be the next regulation, environmental regulation. The strategies and our team have put in place to improve their efficiency and the management of the infrastructure is first the decommissioning, remove all equipment which are not necessary to make some place in the data room. The second technology is the urbanization with the segregation of the equipment, which is a better layout of the room The first point is a containment with cold aisles and hot aisles to segregate the flow of air to refresh and to cool the data center. And the last point, which is a main point for me, which is part of my presentation, is the monitoring. And in order to put in place all the tools able to help them to monitor their efficiency.
Okay, Jean-Marc, thank you very much. I have more questions, but I'm sensitive to time, and I do see that I have a question from the audience. Now, it obviously goes without saying, one of our outputs for the ICT Footprint project is to try and establish and attain as many success stories as possible. So if you do obviously have any, Jean-Marc, that you can share with us that we can put up onto our web platform, or those organizations that can join our marketplace, then I do invite you to please send those over to us. But the question to our audience before we conclude is, do you disseminate best practices so that companies using the KPIs and defining targets have suggestions on how to improve their performance?
Yes, and it was part also of my promotion I put at the end of my presentation. We try to disseminate best practices, and this is why also we have created this non-governmental organization, EG4U, to promote this type of KPI and best practices. We are working also in liaison with the other standardization organization and the other group which are part of European framework of regulation. Well, what I can say more, I think we have to exchange, people have to participate also to the life, and we will be happy also to integrate our feedback and best practices for other company. Currently, we are really at the beginning of the implementation of our organization, and I'm pretty sure that soon you will find a lot of interesting information on our website.
Okay, Jean-Marc, I'll stop you there. In fact, I went back to your slide so the audience can pick up information about the EG4U, your details clearly, and they can get into contact with you directly. Thank you once again, Jean-Marc. We're moving on to our second speaker of the day. We have two. It's both Fadri Casti and Teresa Levova from EcoInvent. You missed the introduction at the beginning. I apologize. Fadri is responsible for the worldwide sales of LCA database and is the driving force for EcoInvent strategic development. And Teresa Levova is a project manager and environmental engineer at EcoInvent as well. So first, over to you, Fadri, who will begin the presentation on the introduction of the EcoInvent database. Thank you.
Thank you, Silvana, and hello to everybody who joined this webinar. I'm going to start with the presentation, just a few slides about EcoInvent, and then I will hand over to Teresa, who will tell you more about our products from a technical point of view. So what is EcoInvent? First of all, EcoInvent is a life cycle inventory which was founded by 5 Swiss research institutes in the late 1990s. They decided to put their work together to create a unique Swiss national life cycle inventory. In the meantime, more than 15 years later, we are the world's largest transparent LCI database. This includes more than 12,000 data sets and more than 7,000 licenses have been sold and used by several thousand, tens of thousands users every day in more than 80 different countries. If you would like to know more about EcoInvent, just a short introduction, please visit our website and click on the video. There's a short introduction video there. So what can you do with EcoInvent? Why EcoInvent? EcoInvent offers different things like calculating carbon footprint or GHG greenhouse gas protocols, or you do full LCA studies, life cycle assessment studies, carbon accounting, or life cycle costing. We have also prices. Every data set has a price. And all this is compliant with the ISO standards 14 series. So what's life cycle assessment? We see life cycle assessment, we go alongside the whole value chain of a material or product that starts with the natural resources and goes stage by stage until the disposal. And there you can go alongside this value chain, and you see the hotspots where you have different environmental impacts and so on.
Yeah, so I'll take over now. What does EcoInvent offer? What does the database, what kind of data are basically available in the database? We have a wide variety of environmental data. We have, for example, agriculture products. We have construction materials, electricity production. We have transport, of course, in the database. We have, for example, wood or metals. I mean, all in all, we have environmental data on products basically from many different fields. So what can EcoInvent offer specifically to the ICT sector? So we can offer environmental data on the majority of the products and services present in the supply chain of the products of the ICT sector. So as Fadri was talking already in the slides before, is with our data are usually being used for different kind of studies. So our data are being used for carbon footprinting or full LCA studies. And in case of ICT sector, of course, when you go along the supply chain, it starts, for example, with mining of metals. So in the database, we have environmental data for gold mining, production, copper, silver, lithium. Then when you take the next step, you of course have to process the metals, and you have to produce the electronic devices and the batteries, which are later on used also in the ICT sector. The packaging of the product is part of the life cycle as well, of course. Then once you have the product, once you have the electronic device, of course the use phase so when it's running itself, so the electricity consumption usually is next crucial step. So we have data on this as well. And then disposal of the electronic devices. So we have, of course, data sets on the treatment of end of life of different products. So basically what happens when you dispose of 1 kilo of unspecified electronics in Europe, when you dispose it in India, or when you dispose it in China. So we have this end of life scenarios in the database as well. Of course, especially for the ICT sector, but for any other sector, one of the crucial points is, of course, electricity production. So EcoInvent database covers around 89% of the world electricity production. So what that means, it means that we have hundreds of data sets which represent electricity production in different parts of the world. So we have electricity production typical for Switzerland, for England, for China, or for India. So when you have your product and you are thinking on what is the difference between operating the same product in Europe and operating it in Asia, in India, for example, or in China, you can use our data and see the difference in the environmental impacts of operating these products in different countries. Now I tried to kind of bring it closer to what the EcoInvent data can be used for and how does it connect to the ICT sector. So I kind of picked up a few phrases I found on internet which you might notice yourselves. For example, there was a statement that Fairphone targets sustainable material sourcing. So how can EcoInvent data support this statement, or how can you use the data to make this statement? Basically, EcoInvent has environmental data for mining of all the main metals. So we have data on gold mining, copper mining, silver, lithium. Basically, what are the environmental impacts when you produce these metals? So in order to be able to say the metals which we are using to produce our products are sourced sustainably, you need to have the data to be able to say that. Another statement, Facebook boasts green data center in Luleå in Sweden. You might have heard about this news. So basically, we had already the presentation before which talked about energy consumption and how to lower it. So you might be considering when you are in a position as Facebook, for example, that you have the option to move your servers to another country, then what are the differences in environmental impacts of having the servers in Sweden or in the United States, in California or in China or India? Again, we have the data which would be able to give you the answer. What would be the best move? The next statement I found, Tesla's electric cars aren't as green as you might think. So again, you need the data to be able to say this statement, to be able to say something like that. And EcoInvent, for example, has data on lithium mining. Lithium is then used in batteries production and electric car operations. We have data on disposal of this battery. So what happens at the end of the life? And there you can really see in numbers on what is important, whether the production of the car itself, the operation during its lifetime, so whether the electric car is driving in Norway, Sweden or China, and then what is the environmental impact of disposing of the batteries at the end of the life. And the last statement I found is of Apple. Apple says our comprehensive carbon footprint is several million tons of greenhouse gas emissions. Again, if you want to calculate for your reporting, environmental reporting, or for your marketing activities to show how environmentally friendly you are, you again need to have the data. And again, this is a point where the EcoInvent database steps in and can provide you the basic average data for every country. So you might know we are using, I don't know, 1 kilowatt hour of electricity in China. If you match it with the data we have in the database, you are able to see how much carbon footprint you actually emit by using this 1 kilowatt hour of electricity.
All right, so it's me again, Fadi. I'm going to finish this presentation with a few reference we have. Our customers are mostly multinational organizations, so it's really, as Teresa mentioned, it's a world database. Here a few customers in the ICT market, but then also other ones, well-known companies who are their activities all over the world. And then very important also, we are working with leading universities. They're customers as well as data providers. They use our database for their research, but they also deliver their own data from their environmental departments. So that's a very important exchange, and gives us also always the possibility to keep our database on a high quality level. All right, that was it. So
Teresa, thank you very much.
Thank you
for your presentations.
You're welcome.
Most interesting. I do have a couple of questions before we move on to our final speaker, if I may. I think it's clearly today data is on everybody's lips, and the whole, you clearly have a wonderful asset here. But your process of collecting your data, can you just run us through that without obviously disclosing anything privately? But how and where does EcoInvent collect its data to make up your LCAs? How does this work?
Sure. Well, the EcoInvent Center is basically just a management center. So we are in the middle of basically the activities, and we have a lot of partners. We have a network of partners all around the world. It's the universities. You could see the logos on one of the slides. So we are working with universities all around the world which have their own separate projects on, for example, how environmentally friendly is palm oil in Brazil. And during these projects, they collect a lot of data. data. A lot of it is then published in scientific journals or articles, and we either can then contact directly the universities and ask them that they will create for us the data set. So then we have a complete data set on palm oil production in Brazil, for example. Or we manage to find external finances which help us to launch and finance this project. So when there is something specifically we are looking for example, we know that the Airbus, for example, needed a composite. So they needed for production of plane or cars, you need specific materials. Then we might try to find for the finances and find the consultancy and academic partners which are then able to launch a project during which they collect this data. Sometimes it can be, we have a lot of support. So I don't know, we have a very good cooperation with, for example, International Aluminium Association of Aluminium Producers. So there we have really a good data source, which directly the association is providing us with up-to-date data regularly. Sometimes it can be, of course, challenge, because we are assessing an impact on environment, and nobody wants their product to be looking bad. So it can be challenging as well, of course.
Yeah, I think the key words you've said there is that the data is up to date and it's regularly updated. I think that obviously is the most important point, isn't it? That you're verified that what you have is consolidated and
yeah, not necessarily actually. Even if you look at changes of electricity production in past 20, 30 years, of course we are slowly going to more renewables, but the share is still quite tiny. So if you have, and production of electricity from hydropower plants, basically the environmental impacts didn't change in past 30 years. So of course there is a lot of big changes which are going on, especially electronics, for example. That's moving fast. But then there are other parts of the production where it's better to have some data than no data. And in a moment you identify that this is something which might be crucial for us. For example, I don't know, we are producing, Tesla is producing electric cars, and then they see the hotspots might be the production of the battery and the lithium mining. Then it's then up to them to go in. We provide the average data. They see based on average data that there is a problem, and then it's up to them to go in and to find out who are their suppliers and how are their suppliers mining the lithium, and what are the specific environmental impacts there.
With our partners in ICT Footprint, Deloitte Sustainability and Eurocities, one of our tasks is to actually pull out a self-assessment tool, which is something we're working rigorously on to get end users to try and do their own self-assessment within their organizations, and also eventually for services too. One of the questions that's come up from the audience is also related to a challenge we have in the development of this tool, is in the sense of getting the correct data, that there are benchmarks against what's out there already on the market, that you can fully assess that what you're doing is correct. And the questions come up here, which it says, as the obviously the ICT is a ever evolving scenario, and with new products, new technologies, it's a very confidential, sensitive sector. How reliable environmental data how reliable are the data lifecycle inventories is the question, and whether is the representativeness of your environmental data. I think I might have to take that as a last question before moving on.
Yeah, sure.
Who would like that? Teresa or Fadri?
I think I'll take this one.
Yeah, that's better for you, yes.
Of course, every single data you collect has a certain uncertainty, and that's the whole discussion about whether there is a global warming or climate change and so on. And it's not black and white. Of course, ideally we would have data from every single producer, and ideally we would make an average which would be really based on primary data collection. In reality, nobody has this data. So basically, the only thing which we can offer is that we provide these averages of best available information, which can be used as a benchmark. So you can create your own collection of your own data and your own supply chain, and then you can have a look on how you look in comparison with our data. And there are already conclusions. We always say, if you talk to a person who is doing life cycle assessment and ask him or her a question, the answer you will most probably get it depends. because it's very hard to get answers from LCA because there is so many factors which comes in and basically changes the result and changes the conclusions. But what I think is important is to start diving in, and these obvious things will start pop up. For example, I don't know, assessment of environmental impacts of cars. In case of cars, the only thing which matters, or 80% of the impacts, comes from the use of the cars. So it depends on what is the fuel you are using and how much of the fuel consumption the car has. And the never-ending discussions on how we are going to recycle the car at the end of the life, of course it matters as well. But it's a 10% of the whole life cycle. So, you know, LCA can give you this kind of heads on where you should focus, what is important for you. And you might discuss till the eternity whether the numbers are reliable or not. But it will give you kind of a path which you should follow, direction.
I mean, surely, I think this came up in the last webinar as well, the more best practices you receive and analyze, the better benchmark you're able to pull out, surely. Because you can create some averages, right, can't you? Okay. Okay, I think with that, let's stop there. I know there are some other questions in from the audience. Let's see what happens and how we fix the timing at the end. But I'd like to thank you both for your intervention. Our final speaker of the webinar is Berina Delalic. She is a component leader and supports the multEE project. multEE is one of our synergy projects funded under Horizon 2020. And if you go onto ICT Footprint, you will see a list of all the projects that we engage with. And multEE is also there. Berina is a technical expert for a project on open regional funds for Southeast Europe and energy efficiency implemented in the West Balkan countries. And she is responsible for establishing web tools for monitoring and verification of energy efficiency measures. So with that, I'd like to pass the floor to Berina, whose presentation is Monitoring and Verification Platform. Over to you, Berina. Thank you.
Thank you very much. Good afternoon to everyone. I'm very happy to be part of this webinar today, and very impressive work that I've seen in past 45 minutes. Congratulate to my colleague presenters. I have only, we only all had 10 minutes, so I hope I will keep your attention in the end. So I'm coming from a GIZ project, Open Regional Fund for Energy Efficiency, working in Western Balkan. And we are partners at this multEE project. As mentioned, it's a Horizon 2020 finance project. And this project started actually in 2015 in March with the aim to improve consistency and quality of this whole basically policy cycle in a field of energy efficiency, especially having in mind that different administrative levels are also involved in this field. So we are having two main goals. One goal is to develop and introduce innovative monitoring verification schemes. And the second goal is to improve this vertical coordination between different administrative levels and between different institutions that are having responsibility for some part in the energy efficiency sector. So basically, within this first part, developing innovative schemes, we developed this monitoring and verification platform. Now, I have to say that the idea for the MVP actually started in Open Regional Fund for Energy Efficiency. It started here in Sarajevo. My colleague, Mr. Armin Teskeredzic, developed the core idea and why do we need this kind of a web tool that could assist in measuring progress towards energy efficiency targets. And then within multEE, we developed it, and we are still preparing it for our partners in the European countries. Now, when I say energy efficiency targets, I have to mention that in order to involve all different institutions, we are offering here that different plans can be monitored with MVP. So energy efficiency targets are not only the national energy efficiency targets, but it could also be referred to some municipal action plans or regional plans, which are often can be found in the European countries. So the MVP applications, or called monitoring verification platform, is based on collecting the data using the bottom-up approach. So the MVP contains the data about plans, about planned measures, and the expected energy savings or CO2 emission reductions. We all know that some plans have targets with energy efficiency, and others also have targets with CO2, but we have seen that a lot of measures are very similar in these two fields. So basically, the energy efficiency, the savings in energy could be transferred to the savings in CO2 emissions and vice versa. On the other hand, the MVP also stores the data about implemented projects and implemented measures and their corresponding achieved energy savings and CO2 emission reduction, but as well also implementation costs. So this information also can be used and can be very valuable in completing this policy cycle, basically in assessing your previous progress and planning new measures. So when you have these two types of data in one place, in one web platform, then you are able to monitor the progress of different plans, particular plans, but also you're able to see how the different plans contribute to, especially how do the plans on lower levels, municipal levels, contribute to the national plans. MVP, the engine behind the MVP is actually the bottom-up methodology. The bottom-up methodology is a set of simple algebraic equations which are developed on the principle that energy savings is calculated as a difference between energy consumption before the implementation of measure and energy consumption after. Corresponding CO2 emission reduction is also based on the same principle, very simple CO2 emission before, which is calculated by multiplying the energy consumption with the emission factor for the fuel, and also the same is calculated for after the measure. Now, this bottom-up methodology is within the multi-project, we have developed a set of a long list of methods which we found that are very common, related to common energy efficiency measures in the Europe. And a lot of measures are also referring to recommendations that are coming from the European Commission. They already provided a small set of bottom-up measures. And I have to say that most of these measures are related to building sector, especially non-residential buildings, which a lot of energy efficiency measures are implemented by public authorities. Also, we have measures in public. We have methods for the measures in public lighting, in transport, and a few of them are in industry. Now, since the information and communication technology is, well, we all know it's a part of everyone's everyday life, and we are all using it no matter what we do or where we do. We were pretty certain when we started our communication with ICT Footprint that some of our measures are tightly connected to ICT, to reducing the ICT footprint. And here I would like to present you two of the methods that we found out that are very much connected to ICT footprint. And one of them is basically replacing or installing more efficient office equipment. And here I have extracted the equations from the equation from the bottom-up methodology, which presents how to calculate the total final energy saving when you are having this type of a measure. Here, I would like just to say that there are actually in the bottom-up methodology that we have developed, there are a few variations of this equations, depending on the type of the mode that you are targeting. So, if you're only targeting active mode or standby mode, there are some variations of this equations. However, you can see here which parameters are needed to calculate what has been done with the energy consumption when implementing this type of a measure. The CO2 emission reduction is very simply calculated by multiplying this resulting number for the total final energy saving with the emission factor for the electricity, which is, of course, specific for your country. The second measure that I have extracted here is the measure of improving central compression cooling system, and we thought that this would be very important for the server rooms. And here is also the equation for calculating total final energy saving for this type of a measure. Also, the reduction of CO2 emission is done in the same way as for previous measure, by multiplying this total final energy saving with the emission factor for the electricity. I only made a small screenshot of one of the forms of MVP just to give you a sneak peek, and I wanted to mention here that the idea for entering the parameters for the calculation is that you have the possibility for the free entry, but also to choose from a drop-down menu some reference values if you don't know exactly what is the consumption of your equipment. This is the part of the form for the office equipment. And after you put in all the data, then by pressing calculate, you simply you can get immediately the energy saving and CO2 saving done that are coming from this type of a measure. Since I don't have more time to show you the MVP, I would like to invite you to test the MVP by yourself. We provided a test link and short tutorial on our multi website, so please feel free to try it, and of course contact me anytime if you have any questions about it or if you would need any help with testing the application. Thank you.
Berina, thank you very much for that very interesting presentation. I know we have it's not a question, we have a point in the audience comments that you do have a final event at the end of June in Vienna, so that's a good plug for you where you'll be presenting multi there. Maybe we'll be able via our Twitter feed on ICT Footprint send out the link for everyone to access that. So with this, I do have a question for you, Berina, and I think because, as we said before, our objective is also to pull out tools. We mentioned the self-assessment tools within ICT Footprint. What we'd like to know is what biggest challenge multi project had when developing its MPV tool.
Well, the challenges were many, but maybe at this point I would say that one of the biggest challenge for MVP was to keep it simple because this was the main idea from the beginning. In order for the people to use it actually and to not to be frightened by it, we knew that it needed to stay simple. And when starting to develop something from the scratch, which was that was the situation with MVP, everyone has a lot of ideas how it can be used and what kind of a features should be entered and different things. But Mr. Teskeregic, who's working also on this and development, he's very focused. So he knew that we need to stick step by step, and of course, upgrade is always the idea, and we already have some things on mind, but let's take it step by step and not frighten people with a huge application, a lot of features, but to provide a simple tool.
Yeah, keeping it simple has to be key. I'm sensitive to time. We have 2 minutes left. Quick question from the audience, Berina. Are your tools aimed to be used by the member states to elaborate their national energy efficiency action plans to be submitted to the EC, to present their progress in improving energy efficiency and the measures taken? I don't know if you have this answer, Berina, or you can address this after.
Well, I can answer it immediately. Yes. Well, yes, the MVP is aimed to assist member countries to collect data about MVP, because in that sense, if you include also municipalities and different administrative levels, then you also have the data from the field, the bottom-up data, and on the national level, you can monitor the progress, and you can also see how those measures contribute also to the national targets. And of course, on the national level, you also collect data about this. So yes, the MVP is developed for the countries, and of course, I have to say that it can be easily adapted to any administrative structure of any country, and including the climatic data, because we use heating degree days and some other data. So it's really developed to be easily adapted to different countries.
Perfect. Thank you, Berina. Now, with that, I'd like to, with 1 minute to go, thank all our 4 speakers again for your very interesting interventions. Jean-Marc, do bear in mind, audience, he does invite you to visit the ETSI website or the EG4U for follow-up on what he discussed today. Badri and Teresa described EcoInvent and the huge database at LCI, so please look them up and have a look what they're doing. And we invite you to look at the demo tool of the MVP that multi-project has put together. And with that, here is some information. If you're not joined with us with ICT Footprint, look at the indications, see if you'd like to join us for the webinar in the future, and thank you very much for joining, all of you. If you would be interested in joining our 6th webinar, then please do drop us a line. We'd be very happy to have you with us. Thanks once again to our speakers, and we wish you a lovely day. Thank you very much.